So before we move on to talk about equilibrium, let's just kind of simplify this crazy AE function. I mean, there's so many letters in it right now. I know it's probably a bit overwhelming, but let's just simplify it a little bit using kind of the same technique that we did in class, well, our last class together, So I created a video, I think, going through some of this algebra in case you're one of the students who couldn't make it or didn't feel comfortable coming. So make sure you review that to kind of see that we're basically doing the same thing here with redefining certain variables and things like that. So we're just going to start to collect terms together. All right, so when we added government purchases, taxes, and net exports, this is the AE function that we came up with at the end of the last video. So let's start simplifying from here. So now AE equals, and we're just going to collect all the terms that aren't multiplied by y. We're going to collect all those things together, and then we're going to collect all the terms that are multiplied by y. So all the autonomous aggregate expenditures, everything not multiplied by y. So we have these terms here. And then we can have everything multiplied by y, and we have this first term and this last term. All right, so remember, this is autonomous aggregate expenditure. So it's a level of aggregate expenditure that doesn't depend on y. And these last two parts that was a pretty bad one, just like class. So this last term is the induced part. So it's the level of desired aggregate expenditure that depends on y. And then sometimes you don't want to keep rewriting. I mean, writing a plus I0 plus G0 plus x or x0 is kind of a pain, right? So let's just define capital A now to be equal to little a plus I0 plus G0 plus x. So all those terms, we're just going to put them together, add them up, and call them capital A. And then we're going to call z b times 1 minus t minus m. And that's all the terms multiplied by y if we kind of common factor it out. And then we can rewrite our AE function as a plus z times y. Where again, a is the autonomous AE, z is that marginal propensity to spend, often called MPS. Not to be confused with marginal propensity to save, which is also MPS. But Z here is the marginal propensity to spend out of national income. So if our national income goes up by $1, our desired level of expenditure goes up by a certain portion of that dollar. Okay, so this is how we're rewriting our AE function. So if we want to think about graphing it like we did in class before, it's going to look really simple. It's going to look just like it did before. We have AE on our y-axis. We had y on our x-axis. We have this intercept of capital A like we see up there. And we have this slope of z. And this is our AE function. And here, again, A equals little a I0 G0 plus x. And z here, the slope is equal to 1 minus t times b minus m. So all we're doing, like we're still representing it with capital A and Z, just what that capital A and what that Z represent are different. If you remember before, the slope Z was just equal, or Z was just equal to B. Now it's different with the government and imports. And so what the next couple slides are going to go through is, underlying some of these changes, talking about what they mean. And then we're going to invoke our equilibrium where actual y equals this desired and kind of talk about what equilibrium looks like now. So that's the plan. So let's go through the next couple of slides which kind of underline kind of what's changed in this model once we've added kind of government expenditure and net export, as well as taxes. Okay, so let's go back to our slides here. Okay, so this is where we're at in terms of slides. This is the next slide after after the end of the foreign export slide. So we're not really invoking equilibrium national income here. We're just kind of setting ourselves up to and kind of explaining what's changed. All right, let's take a quick screenshot of this. So this is working with some numbers that we've seen before. So let's pretend that the marginal the marginal propensity to consume is 0.8. So that means that B that we were talking about before is 0.8. So the marginal propensity to consume out of disposable income was 0.8 before. So if our disposable income went up by $1, we'd be consuming 80 cents of that dollar. Or desired consumption would be 80 cents. Would go up by 80 cents, I should say. Okay, so now we have this tax rate, or total taxes, equal 0.1 times y. That means little t equals 0.1, right? If little t equals 0.1, then disposable income is 90% or 0.9 of national income. So remember, yd equals y minus t, which means yd is y minus 0.1 times y equals 0.9 times y. So yd is 0.9 times y. And then if we want to think about what this means for the marginal propensity to consume out of national income, that's going to start to be less than the marginal propensity to consume out of disposable income. And what I mean by that is if we looked at our consumption function, A plus B times YD, and consumption disposable income now equals 1 minus T times Y, this number together, using the numbers above, would be equal to 0.72. 0.9 times 0.8, which is 0.72. But the marginal propensity to consume out of disposable income is that 0.8, it equals B. Or the marginal propensity to consume out of national income equals B times 1 minus T, which is just 0.72. All right, so moving to the next slide. So this is what we did in OneNote. We expanded this AE function. We plugged in the functional forms and we grouped all the terms. And so recall the slope of the AE function is the marginal propensity to spend out of national income, which we call Z or Z. And so as we showed in this OneNote, let's bring it back up. We did this algebra on the OneNote, and we solve for what this Z or Z is right here. We can see it's changed, right? Z used to be equal to B in our model when there's no government and no foreign trade. But now it's more complicated. And so how has this changed the level of Z? Well, if we go back to our slides, we can see that, again, this is just repeating what we had in OneNote. Z equals the marginal propensity to consume, or B, times 1 minus T, subtracting M. So because T is between 0 and 1, you're taxing either 0%, your tax rate is 0%, or it can be up to 100%. M also, you have to have some positive marginal propensity to import. Because both of these things are greater than 0 but less than 1, our Z is actually getting smaller, which means the slope of our AE function is smaller now. So by adding taxes and imports, our AE function is getting less steep. So let's start to think about equilibrium. So our equilibrium is going to be, condition is the same as before. In equilibrium, actual Y, or actual national income, equals this desired level of aggregate expenditure. So Y equals AE is our equilibrium condition, just like before. And so remember, it's the same reasoning behind this being the equilibrium. If desired level of aggregate expenditure is above Y, then inventories are falling and production increases, so investment increases to make up for those falling inventories, which is going to push production up, which Y goes up. On the other hand, if AE is less than Y, we have all these inventories kind of piling up or accumulating. And so firms don't need to keep making things because they don't need to replenish their inventory. So they start to slow down their production and they slow down their investment in these inventories, which is going to make Y go down. So this is why Y equals AE is the equilibrium. So it's the same reasoning behind the equilibrium before. So what we're going to do is go through an example. Like, let's give some numbers, a numerical example for what different numbers for these, A's and B's could be equal to, and kind of talk about how you'd solve for equilibrium. All right, let's go back to our OneNote document here. So here's where we kind of derive the AE function and graphed it out. So let's just do an example. And so let's imagine my writing is just as bad as in class, so apologies for that. Remember, AE equals C plus I plus G plus NX. And now we're going to make the same functional forms. We're just going to give, numbers for these different letters that we had before for A and things like that. So let's imagine our consumption function is 30 plus 0.8 times YD, or disposable income. Investment, which is a constant, is 75 billion, million, whatever you want. Scroll down a bit. I'm going to assume that government purchases are 51. And then our net export function is 72 minus 0.1 times Y. So this is that exports. And this second term is the imports. So it's saying our marginal propensity to import is 0.1, for instance. And let's imagine our tax rate is 0.1. So our tax revenue, or capital T, equals 0.1 times Y. Okay, so let's take these numbers of this example, and we're just going to plug in these functions into our AE function just like we did before. So AE equals 30 plus 0.8 times YD plus 75 for investment plus 51 for government expenditure plus 72 for exports minus 0.1 Y for imports. Now again, we have to deal with this YD. So remember, YD equals Y minus T. We did this on the slides already, but so this is Y minus 0.1 times Y, which is equal 0.9 times Y. So we're going to plug that in. So AE equals 30 plus 0.8 times 0.9 times Y plus 75 plus 51 plus 72 minus 0.1 Y. So if we collected all these terms that are autonomous, is 30 plus 75 plus 51 plus 72. That's that autonomous part that we've been calling A, or capital A. And then we have this induced part, which is 0.8 times 0.9 minus 0.1. Put that in big brackets, times Y. And so this part is the Z. And so AE equals So 30 plus 75 plus 51 plus 72, 228 plus 0.8 times 0.9 is 0.72 minus 0.1 is 0.62. So times 0.62 times y. So this is what our AE function looks like here. So let's go back to the slide since this is the example used in the slides. All right, so here's a table of exactly those numbers that we were just using in the OneNote. So the second column here is giving the actual level of y, and it's varying that going up to 0 to 150, 300, 600, 900, and seeing what happens to the different levels or different components of desired aggregate expenditure. So these are the individual components or the next 4 columns. And then finally, we add them all up to get this AE function. And so equilibrium, as we talked about before, is when y equals AE. So in this second column here equals this last column. And so at this point, we can see just by this table, it's going to be at 600. But again, we don't want to just like have to make a table like this every time we want to solve it. We'll solve this numerically by setting AE equal to y. So if we go back to our OneNote here, equilibrium is AE equals y. That's our equilibrium condition like we just talked about. So I'm going to reverse them a bit, but 228 plus 0.62y equals y. 228 equals y minus 0.62y. If we solve for y, we're going to get 600. So it's just invoking equilibrium condition and solving for it. So the other way to solve this, like the more general way of solving this, is to again invoke equilibrium, which I'll make sure is on the screen this time, which is AE equals y. And we know the functional form of our AE function in that it's A, capital A, plus Z times y equals y. Then we solve for y and we get A over 1 minus Z. Now we can just plug in what this capital A is and what this Z is, and we can just solve for it. So we know that capital A is 228, since that's the intercept of our AE function. I'll scroll further up to show you. That's our intercept of our AE function. And Z equals 0.62. If we plug this into our calculator, we'd get 600 as well. So we can always use this kind of second way as like a quick way of solving the model once we figure out kind of what this A and what this Z equal. All right, so this next slide is just going to graph that out. So if we click on the next slide, it's just making that graph where we have this AE function, which again, the intercept is 228, that capital A is 228. Z, or the marginal propensity to spend, is 0.62. That's the slope of the AE function. And we're going to find equilibrium by setting the AE function equal to y. And so the equilibrium function graphically, as we've talked about before, is this 45-degree line. Because at every point along that 45-degree line, the value on the y-axis equals the value on the x-axis. So that's exactly this equilibrium condition. So when this AE function crosses this 45-degree line at point D, that's equilibrium. So this is what equilibrium looks like graphically for that numerical example. Next, we have to talk about changes in equilibrium. So what happens when something in capital A changes, and what happens if something in Z changes.